A very good morning. My name is Shubham Shukla. So today we are going to deal with a very interesting topic, which is radial basis function. And radial basis function, as I have told you yesterday also in my previous class, that it is the part of instance-based learning. So about instance-based learning, I have discussed in detail yesterday. So I have told you yesterday that there are three important algorithms which are used in the field of instance-based learning. First is the k nearest neighbor algorithm. Second is the radial basis function, and the third algorithm is case-based reasoning. So about radial basis function, let me tell you that it is the very important algorithms and used in making the learning model, and it is used in the field of machine learning and to make the model learnable, to make the machine learnable. So the very use of this particular algorithm is in the field of approximation function as well as in pattern recognition. So as we all know that pattern recognition is one of the important aspect these days, and perhaps a very glamorizing field of research where we can detect the face with the help of machine. So in order to make the machine learnable, in order to make the camera a highly intelligent camera, we use these type of learning models to make them intelligent. So the very genesis of the radial basis function is entirely dependent on Gaussian potential function. So before going to deal with Gaussian potential function, let me tell you that what is Gauss function. So in mathematics, Gauss function is referred to as the Gaussian, and it is the function where f of x equals to exponential of minus a minus b ka whole square upon 2x square. So this actual function is being given by the famous scientist whose name was Carl Friedrich Gauss. So let me tell you some parameter about Gaussian bell, that what is actual Gaussian bell. So as you can see over here, this is the graph of Gaussian function, and this is the Gaussian bell I have drawn over here. So let me tell you that what is Gaussian bell and why it is used. So Gaussian bell or the Gaussian function are often used to represent the probability density function, right? So when we are having the function when we are having the density of population, then we use these type of function which is known as Gaussian potential function. So this peak represents the Gaussian bell. So the height of this peak is being represented by A. The position of the center, suppose this is a center, the position of the center I have marked over here, this is the center, it is being represented by B, and C stands for standard deviation. Suppose when we talk about population density, then this population actually spread over the large area. So throughout this large area, we can see that there are some specific points, that there are some specific deviation of the function value. So these deviation of each and every point of this Gaussian bell is known as its standard deviation. So sometime it is also called as the width of the bell. Suppose this is the Gaussian bell, and if we want to know about standard deviation, then we can call it that this particular width is the standard deviation. So in brief, if somebody wants to know about standard deviation or Gaussian function, they can go back in my previous videos where I have discussed about Gaussian functions. Now, radial basis function, It is used for the approximation function and recognizing patterns. So basically this algorithm is used in classification problems, and it uses Gaussian potential function. The following form considered as radial basis function as multiple or multi-quadratic function. So in order to deal with multi-quadratic function, suppose we are having quadratic function, we are having multi-quadratic function. So in order to deal with multi-quadratic function, we actually use this type of Gaussian potential function. So suppose this is phi r equals to r square plus c whole 1 upon 2, which is the under root of this particular value, where r is the real number and c is the true cost, right? So we can see over here that here r, sometimes r becomes square, then we can see that r to the power of 3, and here we can see that it goes on the exponential form. So in order to deal with all these functional values, because the value of the function could be anything, it could be r square, it could be r cube, it could be exponential. So when the real number could be of anything, then it is known as multi-quadratic function. Then ultimately the use of multi-quadratic function is being applied. So Gaussian potential function is one of the multi-quadratic function which we can apply in this particular radial basis function algorithm. So before going into the depth of radial basis function, first let me tell you about artificial neural network and the feed forward network, that how actually the feed forward network looks like and how it works. So here you can see the diagram of feed forward network. So the feed forward network is actually categorized into 3 layers. First is input layer, the second is hidden layer, and the third is output layer. So here we can see that these are the points or the nodes we can see over here, and these are the input values. So after designing this neural network, we need to weight these values. I mean, we need to weight these input values, right? So this is the input layer, this is the hidden layer, and this is the output layer. So the connection which is connecting this input layer to the hidden layer is known as hyperbolic connection, right? The connection which is connecting this input layer to this hidden layer is known as hyperbolic connection, as well as the connection which is connecting to the hidden layer to the output layer is known as the weighted connection. Why it is known as the weighted connection? Because the weight is being carried over here, right? After getting the input value, it has been processed, it has been passed to the hidden layer, and the radial basis function is applied in the hidden layer, and after getting passed from the hidden layer, it ultimately moves to the output layer. So this is how the feed forward network actually works. So in the case of radial basis function, the density of the hidden layer is more, right? Suppose we can see over here that this is the hidden layer and this is the input layer. So in the case of radial basis function, the density of the hidden layer is more than the density of input layer. So here we can see that m is the density of the hidden layer and n is the density of the input layer. So we can ultimately see over here that m is greater than n. So again, I have draw the very specific diagram of feed forward network for radial basis function, and here we can see that these are the input which we used to assign, right? We used to assign the values of x. These are the input layers, right? And then we used to make the hidden layer. So h stands for hidden. So here we can see that after hidden layer we move to the output layer. So based on this particular network, based on this particular feed-forward network, I came into this function, I came into this formula, which is f of x equals to summation j equals to 1 to m wj hj of x. So what is wj over here? It is the weight. Actually, when we talk about the function, so the function is the sum of all the weighted layers and all the hidden layers, right? The output function of this particular feed-forward network is the sum of all the weighted layers present over here, as well as all the data present in the hidden layer, or the function present in the hidden layer. So each and every hidden layer of radial basis function consists of the transfer function, which is Gaussian in nature. As I have already discussed, that radial basis function, the very genesis of the radial basis function, is entirely dependent on the Gaussian function. So here, if we can see that this is the hidden layer. So hidden layer is the central part of any neural network, right? So all the processing of the network is being done in the hidden layer. So when we talk about this feed-forward network in the case of radial basis function, so what function is applied over here? The Gaussian function is applied. So with the help of Gaussian function, it will produce the output, and the output will then be weighted, right? There must be some weight will be assigned to the output being produced by this hidden layer, and then that output will be carried forward to the output layer. So this is the function for Gaussian function, hx equals to exponential minus x minus c whole square upon r squared. So where c is the center, the Gaussian function have two parameters, the center c, and r is the radius for each neuron in the hidden layer. We need to find the distance, and we need to find the corresponding weights, right? So we need to find the distance from in this particular layer, and after finding the distance in this layer with the help of this Gaussian function, we need to find the weight. So let's know that how we can find the distance as well as the weight. So we can see over here that r is the radius or the standard deviation, as I have discussed earlier in the starting, that this we can see over here that 2c square. So r is represented as c over here, and c is represented as the center. So r is the distance and c is the center. So let us discuss now about the algorithm in detail. So how the algorithm of radial basis function actually works. So here we have taken the hidden layer hx is the Gaussian activation function, which actually referred to as the parameters, which consist of the two parameters, which are r and c. So r is the radius of the standard deviation, as well as c is the center of the average taken from the input state, from the input space, defined separately at each radial basis function unit. So how the learning process actually performed? The learning process is based on adjusting the parameters of the networks to reproduce the set of input-output patterns. Now, when we talk about learning process, then we actually need to set the algorithm over here, and then based on that Gaussian function, this particular hidden layer gets trained, and after it gets trained, it produced some weighted outputs. Those weighted outputs being transferred to the output layer, and we receive the final patterns.